In this video, we'll look at example problems to solve for the linear equation when we're given a point and the slope of the line. Here we have 10 example problems. In each, we're given a point and the slope of the line, m. We're going to do the first 5 problems together, and then you can do the next 5 on your own. I'll give you the solutions for the linear equations for each of these 10 problems, so you can solve the 6th through the 10th problem on your own to see if you understand the concept. Before we start solving for these linear equation problems, we want to remember that our points are defined as x comma y, meaning our first value is our x value, the second value is our y value, and the linear equation is y equals mx plus b. Well, in these problem sets, we're already given the slope m, so all we need to solve for is b, our y-intercept. Now, remember, y-intercept is just the y value when the line crosses the y-axis, which is at x equals 0. So this basically is our secondary point where x is equal to 0 and y is equal to b. So we're given our point 1, which we use subscript 1 to represent. So x1 is our x value for point 1, y1 is our y value for point 1. We redefine our slope in terms of our point 1 and our secondary point 2, which is our y-intercept. So rise over run, delta y, y1 minus b, because b is our y value of my y-intercept, and x1 minus 0 in the denominator, because this is our delta x. x1 is our x value of 0.1, and 0 is our x value of our y-intercept. If I rewrite this in terms of b, we get b is equal to y1, so the point's y value, minus mx1, the product of the slope and 0.1. So we're going to use this equation to solve for each of the next 5 example problems. Okay, so here we have our first problem. We have a point at -1, 3, that's shown here, and I could draw a line of slope -1 and make sure it crosses point 1. Now, drawing that line would be difficult, but I had the computer, so I can make the slope I want, and then I just move the line directly over. But if you're given this problem on a test, you would want to solve using this equation. So let's work through the problem. So y1 is 3, the slope is -1, and x1 is -1. So that's what I have here. So I have 3 minus 1 is equal to 2. So my y-intercept is 2. I look at my graph, and it does match. I have a y-intercept of 2. So all I have to do at this point is plug in my slope -1 and my y-intercept 2 into my linear equation. Y equals -1 times x, or -x, plus the y-intercept 2. So, this is really basically a one-step type of problem. But maybe I want to check. So what can I check? Like I said earlier, we have 2 points. We have point 1 here, and we have point 2, which is our y-intercept. So I can use those 2 points. I know how to solve for a slope, having 2 points. So I can check to make sure that my slope is equal to -1. So I'll use point 1 and the y-intercept, and I use a delta y over a delta x. So here we have 2 minus 3, 0, and the denominator we have 0 minus -1. So I get -1 over 1, which equals -1, until that checks off with my slope. So it's an easy way to check to make sure you're applying the y-intercept equation correctly. Now let's take a look at our second problem set. We have -1, 4, and we have a slope that's infinity. Now in the past couple of videos, we've talked about what a slope of infinity would represent. Take a moment to think about what that would represent. And if you remember correctly, this will be a vertical line. An infinite slope is a vertical line. So if that's the case, we wouldn't use the traditional linear equation. There would be no y-intercept, right? You see this line is parallel to the vertical axis, so it will never cross the y-axis. So there is no y-intercept, so you wouldn't use a traditional form. Instead, the x value is -1 at all times. Even in this case, we can check we can check by using point 1 and any other point. And so an easy point is when the y, or when this vertical line crosses the x-axis, right? When y is equal to 0. So that occurs at -1. So our secondary point that we'll check with is -1, 0. So that's basically right there. So if I apply the slope equation, I have 0 minus 4 for my delta y, and -1 minus -1 for my delta x. So again, -4 over 0, anything over 0 gives me infinity, so that checks off and matches my slope of infinity. Okay, in this third example problem, we have a point at 4 and 1/2 and a slope of 0. So basically the opposite of when we were looking at slope of infinity. Do you remember what a slope of 0 represents? Slope of 0 represents a horizontal line. So you see the horizontal line right there, and you might not even need to go through the whole process to solve for b. Well, because we can see that the y-intercept is right there at 1/2. Well, if the slope is 0, y equals mx, the mx part, it'll be 0 times x, so that drops out. And so we just have the y-intercept, or just the y value of 0.5. We can check this again using 2 points, the point 1 and the y-intercept in this case. And so the y-intercept would be 0.5. So apply the slope equation, delta y over delta x. So we get 1/2 minus 1/2, which is going to give us 0 for the numerator. And then 0 minus 4 gives us -4 in the denominator. So you can see that it doesn't matter which point we choose, we'll get the same value because the numerator will be 0. And so this will give us a slope of 0, which checks off. And now for problem 4, we have 0.8, -2, and a slope of -1/4. And so we see our negative slope, because that's a downward slope if you're marching from in the positive x direction. We can apply the y-intercept equation that we set up. So we have -2 minus the product -1/4, the slope, and x1, which is 8. So I have -2 minus 8 over 4, the -8 over 4, which is -2. So subtracting -2 will give us +2. So -2 plus 2 gives us 0. So y-intercept of 0 tells us what? That tells us the origin, or the line crosses over the origin. So now we can plug in my slope and my y-intercept into my linear equation. We got y equals -1/4 x plus 0, the y-intercept, so that drops out. So we just get y equals -1/4 x. And we could check this now, right? So we can check to make sure that this equation was applied correctly to solve for our y-intercept by using point 1 and the origin, which is our y-intercept. So if I apply this slope equation, we get 0 minus -2 divided by 0 minus 8, so delta y over delta x. So this gives us 2 for my numerator. This gives us -8 for my denominator. And that gives us -1/4, which matches the slope that we're given. And for the last problem we'll solve together, we have a point 0, -2, and a slope of 1. Now this one's an interesting one because the point that we're given is on the y-axis. So what does that tell us? That tells us that it already gives us our y-intercept of 0, -2. So if I draw a line across it, I already know without doing any solving of this that my y-intercept is -2 because we're given it. If I wanted to work it out on my own just to verify, you plug it in -2 minus whatever the slope is, in this case 1, times x1, but because this is our y-intercept already, this is going to drop out. So it's just going to be b is equal to my y1 value, which makes sense. So my linear equation is just y equals x minus 2, right? 1 times x is just x. So when you're given the value already, this becomes a very simple problem. You just plug it directly in. All right, now that you've seen these 5 example problems when you're given a point and the slope to solve for the linear equation, try to use the same method to solve for the next 5 example problems. I give you the solution so you can verify at a later time, But first work through solving the y-intercept, then check to make sure that the slope matches. And then you can come back to this video to see if you match the linear equations we show here.